This is going to be just a continuation of the video on graphing linear inequalities. I'm just going to do one more, one linear equality on the graph, and then I'll do a different video for a system. Okay, so this example number one, this is an example where it's not in slope-intercept form. So what I'm going to go ahead and do is make a miniature function table so I can find the intercepts. And the reason I'm going to go with the intercepts is that I noticed that the coefficients of my x and y are both factors of 18. -3 goes into 18 and 9 goes into 18. So probably for me that I would think it'd be easier to graph it that way. What I do is I plug in zeros for my x and y and find out what the other value would be. So if x was 0, that would make this -3 times 0, 0. So I would have 9y is equal to 18. Because remember, when you're graphing a linear inequality, you graph it as its equation first, then you shade a side. So in this case, y would have to be 2 for 9y to equal 18. That's because this wouldn't be here. Now, if my y was 0, I would have 9 times 0 is equal to, well, 9 times 0 is actually 0. So -3x is equal to 18. My x would have to be -6. So now I'm going to go ahead and graph my intercepts. Intercepts are going to be, my y-intercept is 2, and my x-intercept is -6 over here. All right. Now my line style. Because I have a less than symbol, I don't have the or equal to part under it. This is going to be dash line. Remember, we use for dash lines, or we use dash lines for either this or this, less than or greater than. And I'm going to do this freehand, so it's not with a ruler. It's going to be a little bit crooked. Let's fix that. It's way off. Okay, much better. Okay, so now I need to decide which side to shade. Well, the general rule, if it's in slope-intercept form, is that I can use the symbols. And if it's a greater than symbol, I'd shade up. And if it is a less than symbol, I'd shade down. That doesn't help me here. Here, I'm going to go ahead and use a test point. And by using a test point, I'm going to use 0, 0. That's the best test point there is. And it always works unless your line goes right through it. Because I know that basically every point on the top side or every point on the bottom side is a solution. If my 0, 0 works, all of the points on this side are part of the solution, and I would shade the whole thing. If it does not work, that means that none of the points work, and I'm going to shade the other side. So I'm going to try it out. I've got -3 times 0 plus 9, 9 times 0 is less than 18. Well, that's going to give me basically 0 plus 0 is less than 18. And oops, 0. Well, 0 is less than 18 is true, which means that the side that I shade is a side that will be including the 0, 0. So let me go ahead and shade that side. Normally, we would be doing this with pencil and be a little easier. I'll do my best to shade this. It's taking a long time. But you get the general idea. And the reason this line is dashed is, again, this line represents the boundary between the solution side and the non-solution side. By being dashed, I'm indicating that it joins the non-solution side. The reason I can't draw a white line or it would be invisible, otherwise I would, because I would perfectly join it with this left side. When we have the bar underneath, like less than or equal to or greater than or equal to, we use a solid line. And that joins the boundary line with the side that's fully shaded. Thank you for watching, and watch the next video on graphing systems of linear inequalities.